So this is my calculator for making sure my design will meet all the goal. And so I started with the battery, and I found out the easiest ways to do is to just calculate what's the total energy, the kilowatt hour of the battery, and then how much energy it's using. Because different voltage, different amp hour may not be. And also for my case, I need two battery in series to achieve the voltage for the motor I'm using. So I have to put two battery in series per motor anyway. So that was my beginning have a question. And after I know the battery, I pick a motor which is based on the data, how much thrust it can achieve, and the prop propeller size, which is modeled in the CAD to make sure it's fit in the size restriction. And by estimate the total weight of the craft, I know how much thrust each motor need to generate. So the first one is to see if it's enough. So I need 4 motors when each motor is spinning at 50% throttle, meaning I manually enter, let's move over here. Then I manually enter 4 motors and I'll be spinning at 60%, then I'll able to lift on my craft. So we can put more number and then the thrust required is become less, because if you have more motor, each motor need to work less. So let's go, and then that way I know with how much battery I need and the flight time. So I need total of 8, it will have flight time of 28. We need to fly 20 minutes with 10 reserve. We can put more. Say I put 10 battery, it will fly 35 minutes. And the gas, and this is the, so there's 2 factor. The power is divided between the gas and the electric. So I manually allot how much each need to output. And then let's go move on to here. And the weight, obviously, we need to add up the weight of the fuel, the weight of the structure itself, the weight of the battery, the passenger is 200-pound passenger. And then there's the price. I need to know if I'm in the budget. So the price of the electric motor, that's really costs a lot. Electric motor, the electric speed controller, and the prop. Each one is like $1,000. So one set is $3,000, and I need 4 of them. That's all I can afford. I cannot do 8. It might be better, but so, and price of the engine actually include that light plane was about 10 grand. I mean, that may not be included because that can be for myself and not just for this project. And then the engine, there's from the data sheet. Let's go. So I read on the data sheet, if I'm driving at max cruise, which is around 65 RPM, what power and torque I get and the fuel consumption is calculated here. And in turn, I calculate the weight, and which is this is not weight much at all, and it's calculated into the total weight. So this is about 10 kilogram of fuel, which weigh nothing compared to the battery. And I make sure my gas tank is big enough. So those usually come with 5-gallon tank, mostly 10. So 5 gallon is 19 liters, so I have enough. I only need 18 to achieve the flight time. And with that torque, I input to the prop. The prop I match it with the prop, the data sheet, what torque, the power required, and what thrust it produced. And this thrust is added to the total one. Let's go back to C. So here, I account for a 0.1 power loss percent. Is that percent, or I think that means 10%. So yes. So the gas is 58%, electric is 51% with 10% loss. And then all these making sure, because I'm spending this out of all my pocket, that's a lot of money. So I don't want to just build it and not know if it will work. So at least it has to work on the spreadsheet, and maybe all the inefficiency will add up, or the problem I'll face during manufacturing, and probably there's extra weight I didn't account for, adding all the nuts and screws. So this is where I'm at with this Excel calculation for design.